Want to collect public social media trends automatically without paying for expensive APIs? In this screencast, you will build a clean, pure Python scraper that parses web pages and extracts valuable user data safely and efficiently. Welcome. Today we are diving into Python automation by building a lightweight social media data scraper from scratch. Scraping public feeds allows researchers, marketers, and developers to analyze trends, aggregate public posts, and monitor brand sentiment in real time. Instead of relying on restricted or costly platform APIs, we will use Python's built-in libraries to parse public HTML structures directly. Throughout this lesson, we will cover how to fetch web pages, extract specific HTML elements cleanly, structure our gathered data, and handle common networking quirks like rate limiting or missing tags safely. Before writing any code, let us break down the standard web scraping pipeline. Every successful scraping script follows a clear sequential path. First, we send an HTTP request to fetch the target page's raw HTML source code. Next, we parse that raw text into a searchable DOM structure. After parsing, we isolate specific tags containing our desired social posts, usernames, or timestamps. Finally, we clean the extracted text and export it into a structured format like CSV or JSON. Keeping these stages distinct ensures your scripts remain easy to debug and maintain as target websites evolve. Let us start by writing our first self-contained Python script to fetch a public web page. We will use the built-in erlib module to make an HTTP request and retrieve the HTML contents. To prevent our script from being blocked or mistaken for a malicious bot, we always include a standard user agent header in our request. Let us write this code and run it to verify our connection works correctly. When parsing HTML in Python, many developers immediately reach for third-party packages like Beautiful Soup. However, Python includes a built-in HTML parser called HTML parser in the standard library. This tool allows us to subclass the parser and intercept HTML tags, attributes, and text data as the parser streams through the document. While it requires a bit more boilerplate code than third-party libraries, it gives you absolute control, zero external dependencies, and blazing fast execution speeds for lightweight extraction tasks. Let us implement a custom HTML parser using Python's standard library. We will create a class that inherits from HTML parser, overrides the text data handler, and collects all paragraph texts into a list. This approach lets us simulate how dedicated scraping libraries extract content without installing external dependencies. Let us run this script to see our custom parser capture text from a sample HTML string. Once we extract raw strings from our target pages, we need to organize them into clean data structures. Social media posts typically contain multiple attributes: an author handle, the message body, a timestamp, and engagement metrics like likes or replies. Representing each post as a dictionary or a custom class makes it straightforward to process, filter, and export. Organizing your data early prevents messy data pipelines and makes downstream analytics much easier. Let us write a snippet that takes raw extracted strings, structures them into dictionaries, and cleans up extra white space. Data cleanliness is crucial in social media scraping because user-generated content often contains weird line breaks, emojis, or invisible formatting characters. Let us run this code to see how we normalize and package our extracted records into a clean list of dictionaries. When automating data collection from websites, responsible scraping etiquette is paramount. Hammering a server with thousands of requests per second can crash the host server and will quickly get your IP address banned. To be a polite scraper, you should always introduce random time delays between requests using Python's time module. Furthermore, inspect the site's robots.txt file to ensure you are respecting the site owner's crawling guidelines and avoiding restricted directories. Let us incorporate polite scraping practices into a script by adding randomized sleep delays between simulated request loops. Using the random and time modules, we can ensure our automation mimics human browsing speeds and avoids overwhelming target servers. Let us execute this code to observe our polite rate limiter in action. The final stage of any scraping pipeline is exporting your collected data so it can be analyzed in spreadsheet tools or databases. Python's standard library includes robust modules like CSV and JSON for writing structured dictionaries directly to disk. Choosing CSV is ideal for tabular records like flat lists of social posts, while JSON excels at preserving nested hierarchies and complex metadata structures. Always wrap your file writing operations in robust error handling blocks. Let us write our final complete script that takes our structured social posts and exports them using Python's built-in JSON and CSV modules. This demonstrates an end-to-end data pipeline from raw parsing to persistent file storage. Let us run this script to generate our output data files locally. Congratulations! You have successfully built a pure Python social media data scraper from scratch using only standard library modules. You learned how to fetch web pages securely, parse HTML structures with custom subclasses, clean user-generated text, implement ethical rate limiting delays, and export your structured findings to disk. As a next step, try expanding your parser to extract image links or author timestamps, and always remember to respect website terms of service and robots guidelines in your automation projects. Happy coding!